Good evening to all. I'm Dr. Geeta, Professor, Computer Science and Engineering, K.S.Rangasamy College of Technology. Today I'm going to take 51 CS 701 Data Science. The topic is cross validation. Cross validation is a resampling procedure used to evaluate machine learning models on a limited data sample. The basic idea is to split the dataset into multiple subsets, train the models on some subset, and validate it on the remaining subset. It helps ensure that the model's performance is not dependent on a particular training or test split, providing a more reliable estimate of how the model will perform on unseen data. Different type of cross validations are available. First one is K-fold cross validation. The data set is randomly split into K equally sized subsets or folds. The model is trained K times, each time using different fold as the validation set and the remaining K minus 1 folds as the training set. The final model performance is estimated by averaging the performance across all K trials. In K-fold cross-validation, the data set is divided into a number of K-folds and used to assess the model's ability as new data become available. The next one is stratified K-fold. It is similar to K-fold cross-validation, but it preserves the proportion of classes in each fold. This is particularly useful for imbalanced data sets, where one class may be significantly underrepresented. The next one is leave one out cross-validation. This is a special case of K-fold, where K equals the number of samples in the data set. Each observation is used as a validation set, while the rest are used for training. This method is computationally expensive, but it can be useful for small data set. Next one is the label encoding. Label encoding is a technique that is used to convert categorical columns into numerical ones, so that can be fitted by machine learning models which only take numerical data. It is an important pre-processing step in a machine learning project. Most machine learning algorithms require numerical input, so categorical data must be converted into numerical form. Example: a data set has elements as tall, medium, and short. To convert this categorical column into numerical column, we will apply label encoding to this column. After applying encoding, the height column is converted into a numerical column having elements 0, 1, and 2, where 0 is the label for tall, 1 is the label for medium, and 2 is the label for short height. So advantages of label encoding: it is simplicity, easy to implement and understand. It is efficiency, converts categorical data to numerical format, making compatible with machine learning algorithms. Versatility, works well for original data where there is an inherent order among the categories. Then visual, it shows a simple comparison between the raw categorical data and the encoded numerical data. The next one is random forest. Random forest is an ensemble learning method that combines the predictions of multiple decision trees to improve accuracy, stability, and generalization. It is widely used for both classification and regression tasks. Visually, it shows a diagram of multiple decision trees being combined to form a random forest model. So working principle of random process: first step is bootstrapping. The algorithm creates multiple subsets of the original dataset through a process called bootstrapping, that is sampling with replacement. Next step is decision trees. Decision tree is trained on each subset. These trees are often deep, making individual trees prone to overfitting. Third step is random feature selection. At each node in a tree, a random subset of feature is selected, and the best feature from this subset is used to split the data. This introduces diversity among the trees. Step 4 is the aggregation. For classification, The final prediction is made by majority voting across all trees. For regression, the average prediction across all trees is used. So this is random forest visualization. One is training set, another one is data set. The training data is taken from the decision tree is derived. Then next one is voting after averaging, the prediction is made.